Let's go through these problems, review of what we learned from our lab last class, and then a new introduction on power, which was a deeper thinking warm-up problem, but it looks like you were able to figure it out, at least some of you. So let's start with finding resistance. Resistance is the slope of a voltage versus current graph. So you choose 2 points or you do the rise over run method, and you got a resistance of 2 ohms for resistor 1 and 3 ohms for resistor 3. Ohms is not intuitive, so make sure you memorize that. Please, please. Any questions on A? For problem B, this one could have been solved multiple ways, but this group did it a pretty easy way. They looked at the graph because they were supposed to find the current for a voltage of 10 volts, and they were looking at resistor 1. So they took this graph, went all the way out to 10 volts, and they got a current of about 5, and the unit for that would be A for amps. Did anyone solve this differently? Selka, what method did you use? All right, so you solved for current, right? Current equals V over R. I want to teach you something called the triangle method, or what I also call the cover-up method. How many of you have seen this method either in a previous science class or in a previous math class? Hopefully, no? Okay, so for the VIR method, you take your equation and basically in this unit, we're going to be solving for velocity, current, and resistance interchangeably. But it's such a simple equation that no matter which variable you're solving for, and you have to set it up as VIR at the bottom. If you're solving for current here, you cover up current. V is above R, so it's a division problem. And then when you plug in your values, what's the voltage? Voltage is 10. And current for resistor 1 is 2. You get the same answer as what Sam got by looking at the graph. So I'm going to talk about the cover-up method throughout our problem solving. But all it is figure out what you're solving for, cover it up, and then set up your equation appropriately. Just like what we do for C. If I'm solving for voltage, I can cover up the V. I and R are next to each other, so it's simple multiplication. We already know that from this, but it works no matter what your situation is. So 24 is my current, 3 is my resistance for resistor 2, and then I get a voltage of 72 volts. Any questions? All right, so we are getting into power. And what I want to do right now is I already stamped some of your worksheets, but in your vocab worksheet 2, I never included power, and I would like you to add that 11th vocab word either down here at the bottom or on the back. So on your vocabulary sheet, number 11, I want you to put electrical power. And what we learned about power, at least from our energy unit, we've seen this before, power is work over time. It's the rate in which work is done. When we're talking about work, we're talking about electrical energy. Because remember, work is change in energy, which means energy is being transferred, it's being used, it's being changed. And so when we talk about change in energy over time, we've got current, which is a rate in which charges transfer or a rate in which charges flow, times voltage, which is another term for energy. So if we take a rate, which is current, and take energy, multiply together, we get electrical power. Okay, so you've got your equation, you've got your definition. Now let's do some calculation. First of all, power is current times voltage, but the problem is we need to know what the current is, right? So what Sin did was she used her V equals IR equation. She solved for the current of resistor 1 and the current of resistor 2 using the equation. Another method would be to go to the graph and find the current on the graph for resistor 1 and then the current on the graph for resistor 2, which this would be more of an estimate. It looks like about 2.5 and close to 3. I got a little less than 3, but these are estimates, right? This is more exact. So about 3, not quite, but about 3 amps. Okay, then she's going to use her power equation, the fact that it equals current times resistance. We know the resistance is going to be 5, or sorry, the voltage is going to be 5. I'm thinking current times voltage, and we end up with 12.5 W. Everyone besides Sid, what does the W represent? It's your unit for power. That was from our energy unit, so you want to recall what watts means. And it's significant because if you've ever looked at your electricity bill, you're usually charged for your wattage, how much energy you're using over time. So we've got our calculation for resistance 1, 12.5 watts, and our calculation of power through resistance 2, which is 8.3 watts. Any questions?